And that would be the stuff for the analysis for the chemical reactions lab, what we have to do with our reactions. Okay, so I'm just going to bring that screen back up here. Okay, so at the end of the day, okay, we were looking at these different reactions, and we said that some of them went as predicted and some of them didn't. Right? And obviously what you have to do in the analysis for your lab report is to write these out balanced in both formula and word form. Don't forget to write it in words. Okay, it's real easy to forget to do that. So I just want to review what happened with pair 1 and pair 2, because I know, like, looking at my period 4 class when we were going through it, there were like eyes like saucers, and I was like, did my period 3's eyes look like saucers too? Maybe I went through it too fast. So I'm just going to quickly review that. So if you got a piece of paper, it's probably not a bad idea to write a little bit of this stuff down to help you with the analysis part. Okay? Because I'm also sensing we probably need one more day on reactions before I give you a 30-question reactions assignment that's coming in for marks. Okay? I feel like we need one more day where people can ask questions and get help, okay, and work through all the skills related to reactions. Okay? So that means that we're going to work on reactions today. Tomorrow you're going to get the assignment. Friday we'll start the mole equation. Okay? And we'll work on mole equation Friday, Monday, Tuesday, Wednesday. We'll do a formal unit exam review on the Thursday, and then kind of see what else we need to work on for that last Friday of the unit, and then you'll write the exam on the 13th. Okay? So for this first pair, okay, we said that this should be a double replacement reaction. Okay? The way that it's set up, it looks like it should be a double replacement reaction because they're both ionic compounds. The problem is that the reaction didn't go this way in the lab. This one smelled really bad. Okay? A lot of people would say it was like smelling salts or cat pee or Windex or things like that, all of which contain the same smelly chemical. Okay? That smelly chemical is nitrogen trihydride or ammonia. Right? Now, that's not the only thing, obviously, that was produced in that reaction. There are two other chemicals. But then that makes this not really fit with a double replacement reaction, at least as we understand it. Okay? So what we have to look at here is what's left in the reactants after I take out a nitrogen and 3 hydrogens. Right? So the answer to what's left is this. This nitrogen is gone. And there's only one of the 4 hydrogens left. Okay? So the rest of this reaction is a double replacement reaction between what's now left there. Okay? So sodium hydroxide reacting with hydrogen chloride. Right? Now there's a double replacement reaction that looks like the type we've gone over in class that you can do the pattern for and figure out what the other 2 things would be and then balance the whole reaction. Okay? Does that make a little more sense than what I explained yesterday? Okay. Now, a similar thing happened in reaction number 2. Okay? If we looked at this, we said, first off, the way that this compound here, acetic acid, is written is kind of backwards. It should really be written like this, where hydrogen, which acts as the metal, is listed first, and acetate, which acts as the non-metal, is listed second. Okay? And then we've got sodium hydrogen carbonate over here. Okay? Now when we mix those 2 things together, once again, that looks like it should be a double replacement reaction. Okay? Where hydrogen carbonate has a -1 charge, sodium has a +1 charge, and then we've got hydrogen and acetate here. Double replacement reaction, we swap the metals. Except that one also didn't do that. When we mixed the acetic acid and the baking soda together, it bubbled and fizzed, which means a gas was produced. And if we predict this out the way it's written right now, we'll get 2 ionic compounds, and those are not gases. So it went a little bit different. The gas that was produced in that reaction is carbon dioxide. And there are 2 other products. Okay? Now, it's not a combustion reaction. Nothing burned here. Okay? It's okay to get carbon dioxide as a product in a reaction other than combustion. Okay? So we got to do the same thing in this reaction that we did up here. We got to see what's left of our reactants after we take out 1 carbon and 2 oxygens. So I'm going to take out that and that. So what I'm really left with is this ionic compound reacting with that ionic compound. Now I've got a double replacement reaction, and that will tell me what my other 2 products should be. Okay, questions on that? Now the other ones, remember you don't have to write pair 4 or pair 5 in your analysis, okay, because they're not typical ones, so we're not even going to do those, don't worry about them. But you can do 3, 6, and 7, and those ones are going to follow the patterns that we've learned in class. So if you can identify the type of reaction that's happening there, you can use that pattern and predict the products correctly. Balance and write it in words. All right, so that's the expectation for the for question number 1 in the analysis. Okay. Question number 2 in the analysis wants to know what the 2 precipitates were in this lab. Okay. Reaction number 3 produced a precipitate, and reaction number 6 produced a precipitate. Okay. 6 was the yellow one, and 3 was the kind of gel-like white colored stuff. Okay. So what you're going to have to do for pair 3 and pair 6, or for question number 2, okay, is look at what you predict the products to be. Okay, and then look at your solubility chart. All you have to do is find out if A is soluble or not. If it's soluble, then it wasn't the precipitate. Okay, if this one isn't soluble, that one was the precipitate. And all you have to do is write down the precipitate in pair number 3 was this compound. All right, so all it's doing is checking that you can use your solubility chart. Okay, and I'm going to ask you to do exactly the same thing on your unit exam. Okay, one of the questions on your unit exam is, here's a chemical reaction. Which of the products, if any, are soluble? You just have to look. Are they both soluble? Are neither one of them soluble? Okay, is only one of them? Okay, that kind of thing. Okay, is that a little clearer? Right, so words and formula, make sure the formula equation is properly balanced when you do it. All right, now for some practice here. Okay, I just want to review again, just kind of looking at some of the quiz answers yesterday when I was marking them. I'm still seeing some people not understanding the patterns or even sometimes the rules for how compounds work. Okay, as an example, on yesterday's quiz, and I threw it up, one of the reactions had a non-metal. So let's just say we had chlorine reacting with it was Mg3N2. Okay, so what kind of reaction would that be? That would be a single replacement reaction. I have an element that's reacting with an ionic compound. Now, the pattern for a single replacement reaction is that the element has to swap out the part of the ionic compound that it's like, because the products have to be an element and an ionic compound. But what I saw often was a molecular compound and a metal in the answers. People put the 2 nonmetals together in the compound. When 2 nonmetals combine, do I get an ionic compound? Okay, so that's kind of where I was a bit alarmed, I think I'll say is the right word. Okay, because I saw people going and writing in a molecular compound, and I was thinking, oh, Do people not know the difference between molecular and ionic compounds? It was a bit alarming when I saw how often it happened. Okay, so if we're looking at this one here, okay, we would have magnesium. Who's magnesium's new partner going to be? Chlorine, yeah, okay. The chlorine has to swap out the part of the ionic compound that it's like. So that means magnesium ends up with chlorine, and nitrogen ends up alone. I have to have a metal and a non-metal, and then whatever is left. Okay. Now, because this is a single replacement reaction, I make an ionic compound and an element, so what do I have to check for? Special element. Do I have any? Yeah, nitrogen special. Okay, and this is another thing I saw. Nitrogen comes as a 2. Its charge is 3. But I had a lot of N3s on the other side. Okay, I think people confusing the charge for the number that it comes as. Okay. And then what do I have to do with this compound here? Drop and swap. Okay, so. Okay, looking like that. Are you okay with that one? All right, now if I'm going to balance the whole reaction, 3 is my biggest number. All right, so I'll start with that, and I'll put a 3 here. Okay, my nitrogens are already balanced, but that gives me 6 chlorines. So a 3 here would make that work. Okay, it might have been bromine on the quiz, but it was something like that. Okay, that we did. Just want to make sure everyone kind of understands how that goes. All right, I would like you guys to try the ones that are on the board here. Okay, I'm going to hand back your quizzes from yesterday, and we'll go through them together just to make sure everyone understands. Okay? Okay, so we went over one that was kind of like number 1. I put magnesium in, I think, instead of beryllium, but it's basically the same idea. Okay, number 1, we've got an ionic compound. It's reacting with an element, so we have a single replacement reaction where our element is a non-metal. So that means then that the non-metals are simply going to change positions. And I'll get a new ionic compound, beryllium acting as the metal, but now bromine being the non-metal, and now nitrogen being alone. Right? And since nitrogen is special, it ends up being a 2. This one has to be dropped and swapped. Bromine's a -1, beryllium's a +2, so we get BeBr2. Okay? And then we have to go back and balance everything. Okay? I need a 3 in front of this to balance the berylliums. A 3 in front of this to balance my bromine, so I have 6 on both sides, and there's already 2 nitrogens on both sides. So very similar to the one we did just a few minutes ago. Okay, now here's the thing. If I mess up one of these compounds, then I don't get the marks for the reactants, or for the products, because the products aren't right. And by that same token, I can't get the marks for the balancing, because I can't balance them either. Okay. Even if I balanced whatever reaction I made, it's not properly balanced because it's not the reaction that actually occurred. Okay. And that's what can happen if we're getting confused with things in reactions, is we can lose marks really quickly from one mistake because it compounds itself with the next step. All right. And so if you're looking at your mark and going, crap, it looks like I only made one small mistake, but I lost all the marks for that. It's because that one small mistake affected the second mark, which was the balancing of the equation. All right, now for number 2, we had phosphorus reacting with lithium. Now, if you recall, I told you I don't have that many tricks that I have in the bag. Okay? But this is one of the tricks. If I combine, this is a synthesis reaction because it's 2 elements. When they combine, one's a metal, one's a non-metal. What kind of compound does that make? It makes an ionic compound. What do I write first in an ionic compound? Metal. The metal. Okay, I saw a lot of this written with the P first, which is not how we write an ionic compound. All right, so phosphorus is a -3, lithium is a +1, so we're looking at Li3P for our proper compound there. Okay, and then we have to balance our phosphorus and our lithium. Okay, so really, that reaction was really just checking whether you remembered the rules for writing an ionic compound or not. Okay? Because, I mean, other than that, the reaction's not too difficult. Okay, in number 3, I've got an ionic compound reacting with another ionic compound. What kind of reaction is that going to be? Okay. Double replacement. Okay. In a double replacement reaction, all that happens is the metals switch partners. Okay. So what that means is sodium ends up with sulfate, and iron ends up with nitrate. Now, this was the trick on this one. The other day, I told you sometimes you can't tell what charge a multivalent metal has, so you have to go with the most common one. And a lot of people went with that rule on this one. Except on this one, can I figure out what charge iron had on the reactant side? I can't. That rule only applies if I can't find out what charge it had. And the only way that that happens is if it's a single replacement reaction and iron's by itself to start. Okay? In this case, I can look at this compound right here and find out that, oh, this is the iron that has the +2 charge. Okay? And of course, I purposefully picked iron 2 because I knew 3 was the most common charge and I wanted to see if people would pick it. I know, I'm mean. Okay? But it's kind of these little mistakes that don't really hurt us. I mean, I know you might not be happy with your quiz mark, but remember, quizzes don't count really for anything. Okay? These are the little lessons that are important for us to know. So when we're handing in a reactions assignment or doing reactions on our unit exam, two heavily weighted things, that we do them right. Okay? So I've got now that figured out. I know the charge on iron is 2+. So now I can go over here and say, all right, this is the iron that's 2+. Nitrate's a 1-. Okay, so now I've got that. And for this one here, sulfate's a -2, sodium's a +1. So Na2SO4. Okay, I had a couple of people in my period 4 class. We actually did this question together before we went across. They wouldn't let me take them to the lab until we had gone over that question because they were like, I couldn't make it balance, Coder. It didn't matter what I did, I couldn't make it balance. And I said, what did I tell you it means if you can't get a reaction to balance? I don't know. It means you didn't drop and swap something correctly. Is that exactly the problem they had here? They didn't drop and swap it correctly, right? They had iron with a 2+ charge on this side and iron with a 3+ charge on the other. There's no way you're going to make that balance. Okay? The factors are different. Okay? It's like saying, well, I can balance apples and oranges. Okay, well, maybe you can, but you can't in chemistry. All right, then we got to balance this thing. So there's 2 sodiums on that side. Now there's 2 sodiums on this side. That also gives me the 2 nitrates that are on the product side. And now the whole reaction is balanced. Okay? They really only have to add one thing for that, but that's why they couldn't make it balance. Okay, what kind of reaction are we looking at for number 4? Combustion, yeah. Okay. What are always the products of a combustion reaction? Carbon dioxide and water. Okay. Do I need both balancing rules for this one? Yep, I do, because 2 is an even number. So, I'm going to start with a 2. All right, 2 times 2 carbons is 4 carbons. Now there's 4 carbons over here. Okay, 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. And now I can balance my oxygens. 4 times 2 is 8, plus 6 more is 14. 7 times 2 is 14. All right, questions on that one? All right, what kind of reaction is the last one? We didn't have to do the last one, we only did 4. What kind of reaction is the last one? It's a decomposition reaction. Okay, so that means I'm going to have cobalt and chlorine. What do I always need to look out for in a decomposition reaction?
Like the special ones?
Right, the special ones. Either of these special?
Chloride is, I think.
Yep, chlorine comes as a 2. Okay, cobalt's a metal. Other than hydrogen, there aren't any special metals. So, okay. Now we just got to balance it. Lowest common denominator of 3 and 6, or 3 and 2 is 6. So a 2 here, a 3 there, and a 2 there ought to do it. Okay. So the big thing to remember here, guys, is the steps. Okay, if you follow the steps, you really can't go wrong. Okay, now that means you do have to be able to recognize the reaction types just by looking at the reactants. Okay, and it means you have to know the patterns for the reaction types, and that's just a matter of reviewing them at home. You got to study them. Okay, then put them together. Okay, follow the pattern can tell you what goes with who. Okay, then follow your swaps and drops and all of that kind of stuff. Okay. All right, let's go. Okay, give you a couple more minutes to work on those, and then we'll go through them together as well. Okay, so for number 6, I've got barium phosphate, which is an ionic compound, reacting with copper 2 sulfate, also an ionic compound. What kind of reaction am I looking at here? Double replacement, yeah. Okay, so the pattern for double replacement is that the metals have to switch places. Right, so that means then that copper is going to end up with phosphate, and barium is going to end up with sulfate. Okay, everybody all right with that? Okay, so I need to drop and swap both of those. Now, the thing we just talked about a minute ago comes up again in this question because copper has more than one possible charge. But I don't have to use the most common one by default because I can actually figure out which one it is here. It ends up being the most common one, but I can figure it out from here. Okay, so sulfate's a -2, okay, and there's one sulfate, so the copper has to be a +2. So then I can go over here and say copper's a +2, phosphate's a -3, and do my drop and swap. Right, and then I got to do the same thing here. Barium's always a +2, sulfate's always a -2, so that compound is fine the way it's written right now. Okay, everybody all right with that? Okay, is being able to do that drop and swap pretty important? Yeah, because if I mess that up, I won't get it to balance, will I? All right, so for this one then, we'd be looking at probably balancing the barium first. It's the biggest number. Okay, so I'm going to put a 3 over here. That's going to give me 3 sulfates. Okay, so I'm going to need to put a 3 there to get the 3 sulfates. That's going to give me 3 copper. That's perfect. There's 3 copper over here already. And I've got 2 phosphates. 2 phosphates looks good with those 2 numbers there. Okay. All right, now on your assignment that you're going to get tomorrow, there are 10 questions on there that are just like these. Okay, 3 marks each. The 3 marks are for 1 mark for this, 1 mark for this, and 1 mark for the balancing being right. Right? So on that one, it's a little more forgiving than your quiz yesterday. You could get 1 of them wrong and still get 1 out of 3. But that's all you could get, because if you get 1 of the compounds wrong, you won't get the balancing right either. Okay, everybody with me there? All right, for number 7, we have only 1 reactant. What kind of reaction is that? Decomp, yeah. Okay, so it's going to break down into lithium and nitrogen, okay, according to the pattern. Okay, since I'm making 2 elements, I need to check and see if any are special, are they? Okay, so nitrogen comes as a 2, and now I got to balance everything. So if I balance the biggest number first, I'm going to have to restart. So I'm going to start with my nitrogens here. There's 2 over there, now there's 2 over here, and that gives me 6 lithium. Okay. All right, how many people have done number 8? Okay. Give you a couple more minutes, then we'll do 8 and 9. let's look at 8 and 9 here. Oh, I left that recording. Okay, this is a long blank spot. Okay, so number 9, I got a hydrocarbon reacting with oxygen. What are we looking at there?
Combustion.
Combustion reaction. Okay, so products of combustion are always the same two things, CO2 and water. Okay, that's just something we have to memorize. Okay, it's not something we have to think about. All right, do I need both rules for this one? No, I don't. 9's an odd number, so I can just start with a 1. So there's 9 carbons. Now there's 9 carbons in the product. There's 20 hydrogens in the reactants. Now there's 20 hydrogens in the products. And now I can look at my oxygens. 9 times 2 is 18, plus 10 more is 28. 14 times 2 is 28. Okay. All right, for number 9, what kind of reaction am I looking at since I have 2 elements as my reactants? It's a synthesis reaction. Okay, what kind of compound is that going to make? I got nickel and I got phosphorus. Ionic, yeah, I got a metal and a non-metal. All right, so nickel comes first, phosphorus will go second, and nickel has more than one possible charge. Can I figure out which one it is? I can't figure it out, so what do I have to do? Take the first one. Right, what's the first one? 2 plus? Yeah, good. All right, so we got nickel with a 2 plus, phosphorus with a 3 minus. Okay, we got that, and then we got to balance the whole reaction. 4 is the biggest number, so that fixes the phosphorus. That fixes the nickel. Okay. Some people have done number 10. All right, give you a couple more minutes on 10 and 11, and then we'll go through those 2. No, the whole thing. Like you have it there. Yeah.
Okay, this and this? And this one?
Yes.
Okay.
Here. So for number 10, I've got zinc hydroxide, which is an ionic compound, reacting with potassium, an element. Okay, what kind of reaction am I looking at?
Single replacement.
Single replacement. Okay, in a single replacement reaction, the element replaces the part of the ionic compound it's like. Since potassium is a metal, that means it's going to swap out the zinc, and zinc is going to wind up by itself. So potassium is going to end up with hydroxide, and zinc is going to wind up alone. All right. Since it's a single replacement reaction, I've got to check for special elements, are there? Zinc's a metal, it's not special. Okay, and I got to drop and swap my ionic compound. So potassium is a +1, hydroxide is a -1, so that compound is good the way it's written. Now I need to balance the whole reaction. The only thing that's out right now is the hydroxide, so I need to put a 2 here to balance the hydroxide, but when I do that, it's going to make me require a 2 in front of the potassium on the peroxide. All right, and for number 11, potassium permanganate reacts with calcium nitrate. What kind of reaction are we looking at there? Double replacement. Okay. In a double replacement reaction, the metals switch places. All right, so that means then that calcium will end up with permanganate, and potassium will end up with nitrate. All right, I just made 2 new ionic compounds, both of which need to be dropped and swapped. Permanganate is a -1, calcium is a +2. Potassium's a +1, nitrate's a -1, so that compound is okay the way it's written. And now I've got to go back here and start balancing things. So, there's 2 nitrates on this side, there's only 1 over there. So I need a 2 there. That gives me 2 potassium. Now I have 2 potassium and 2 permanganate, which works out because there's 2 permanganate on the other side, 1 calcium on each side, and I'm good to go there. Okay. All right. I do these kind of slow, and I talk all the way through it. Why do I do that? It's because honestly, if I don't, I'll screw it up. Okay? I talk my way through a reaction every single time because I need to do that in order to remember what the steps are so I don't miss anything. Okay? Now, obviously on a unit exam, it's not really practical for you to talk to yourself, okay, when everyone else can hear you, but it's okay for you to do that in your head, okay, on an exam. There's nothing wrong with that. You need to be able to talk yourself through the different steps. Okay? If that's something, if you're an auditory person, you remember things by hearing them, that's a great way to do it. Okay. Give you guys about a 5-minute break here, and then I'm going to have you do some word ones, okay? Because we're going to get some word ones next. Okay, guys, let's have you guys try 6, 7, 8, 9, and 10. Okay, these ones obviously are with the word reactions, so you have to write out the reactants in formula form and then do the rest of it from there. Okay, so we've got that extra step of you've got to get the formulas for the reactants before you can get started. All right, so for number 6, we got lithium bromide reacts with phosphorus. So that's going to be LiBr. That's a -1 and that's a +1, so that's okay that way. With phosphorus, what does phosphorus look like by itself? Right, it's a 4. Okay, so that's one of those ones that we'd have to be mindful of. Okay, what kind of reaction am I looking at? Single replacement. Okay, and we had one kind of like this on the, wait a minute. No, they're slightly different. Okay, so we got a single replacement reaction, so that means that phosphorus has to replace the part of this ionic compound it's like. So that means it's going to swap out the bromine. Okay, so Li is going to end up with P, and bromine is going to end up alone. What does bromine look like alone? That's a 2. Okay, and this is an ionic compound, so what do I have to do with it? Drop and swap. Okay, -3, +1. All right. Our biggest number in there is 4. So we're going to have to put a 4 in front of this, a 12 in front of that, because 4 times 3 is 12, and then a 6 in front of that, because 6 times 2 is 12. Okay, we just did that one. Yep. We just did that one. So we're not going to do that one again. That's why I had that moment. These are the same questions, but they're not quite the same questions. All right, how many people have done number 8? Okay, I'll give you guys a couple more minutes, and then we'll do the last 3 here. Okay, so don't worry about 7. If you weren't done 7 yet, we already did 7. Okay, give you a couple more minutes on 8, 9, and 10, then we'll look at those. And then I might give you the instructions for that assignment. Okay, we could start on it. So for number 8, we got cesium reacting with sulfur. Okay, so cesium is Cs, and it's reacting with sulfur. Okay, are either of those special? Yeah, which one? Sulfur, what does it come as? Yeah, it comes as an 8. All right, so we got 2 elements here. What kind of reaction are we looking at? Synthesis reaction. So they're going to combine. When they combine, they form an ionic compound, which then needs to be dropped and swapped. Okay? Sulfur is always a -2. Cesium is a +1. All right, so when we drop and swap that, we're going to have CS2S. All right. Now I got to balance the whole thing. 8's the biggest number, so I'm going to need an 8 here, and 8 times 2 is 16. So I'm going to need a 16 there. All right, right, for number 9, I've got zinc oxide, so zinc is Zn with oxygen. So that's an ionic compound. This is a -2 and that's a +2, so that compound is okay. Reacts with rubidium chloride. So rubidium is Rb, and it's with chlorine. This is a -1, I believe that's a +1. Yes. Okay, so that compound is also okay the way it's written. All right, what kind of reaction am I looking at there? It's a double replacement, yep. Okay, so I'm going to have to swap my metals. Okay, so that means then that rubidium will end up with oxygen, and zinc will end up with chlorine. Now that's going to mean I have to drop and swap both of these now. So this is a +1, that's a -2, so Rb2O. And zinc with chlorine, okay, is going to be +2 and -1, so ZnCl2. All right, now I got to balance the whole thing, and I'm only going to need one number. What is it?
2.
Yep. Okay. And then our last one, iodine reacts with magnesium. Okay. Did I forget anything? What did I forget? Special element, yep. Iodine comes as a 2. All right. What kind of compound is that going to make in this synthesis reaction? It's going to make ionic. So what do I have to write first? Yep. All right, that's a -1, that's a +2. Well, at least the balancing's easy. Everybody all right with that one? Okay. Then, let's give you the instructions on that assignment there. Then we'll have even more time tomorrow to work on it because I won't have to give you the instructions. All right, so this assignment is grouped into 3 sets of 10 questions. Each set of 10 questions is asking you to do something a little bit different. Okay, so for the first set of 10 questions, all you have to do is balance the reaction and write it in words. All right, so balance in the blanks, write it in words underneath. All right, that's all you have to do. The 3 marks each. 1 mark for the balancing, 1 mark for the reactants, 1 mark for the products in words. Okay, is how the 3 marks are going to go for that. Okay, so 1 mark is for balancing, 1 for the reactants, 1 for the products. Now, things to watch out for in this first set. Okay, Roman numerals. Okay, when you're writing out names, if an ionic compound is a multivalent metal, make sure that it gets a Roman numeral. Okay, don't over-apply that. Not all of them need Roman numerals. Okay, just the ones that are multivalent. Okay. Similarly, do I need to write a Roman numeral, let's say for iron, if it's by itself? No, I don't. Okay? It doesn't have a charge when it's an element. As an element, its electrons and protons are equal. Okay, so we don't put Roman numerals next to an element, only in a name of a compound. Okay? Because that's where we would have to indicate what the charge is. All right, so that's what you do for the first 10. Write it in words, balance it, and I would also say that if it's a 1, like let's say one of these is already balanced, put 1s in all the blanks. Okay, because if you don't, I don't know whether you didn't know how to do it or did and just didn't write anything. So leave no doubt. If it's a 1, put a 1 in. Okay, and then I'll know that you knew how to do it. Okay, questions on the first 10? Okay. So the second set of 10 questions is giving you the reaction in words, the whole reaction. Okay, reactants and products. So what you have to do is identify what type of reaction is occurring and write a balanced chemical equation for each one. Okay, so each one's worth 3 marks. Okay, 1 mark is for the type, and that's the easiest mark. Please don't forget to do that. Okay, be surprised how many people get 2 out of 3 on all of these because they forgot the easiest thing. Okay, which is to write SR or decomp or whatever beside it. Okay, so 1 mark for the type, 1 mark for the reaction, and 1 mark for the balancing. Now, do we have to be very careful here? Is it really easy to lose 2? Okay. If I don't get the formulas right, then I won't get the balancing mark either. Okay, so you have to be really careful. Just double check everything. Thing to watch for on these. That is the thing that costs people the most marks in that set of 10. Forgetting the special elements, because if you forget that an N is supposed to be a 2 when it's by itself, and you don't do that, you don't get the mark for the reaction, and you don't get it balanced correctly either. Okay, so that's a quick one. Remember to check for special elements. Okay, and of course your drops and swaps are pretty crucial. There's a lot of ionic compounds in here as well. Okay, questions on the second set of 10? All right, the third set of 10, you're predicting the products and balancing the reaction. All right, you don't have to write anything in words here. Okay, you're just products and balance. All right, so you're going to get 1 mark for balancing, okay, and 2 marks for the products. Even if there's only 1 product, you still get 2 marks for the products. All right, I'm going to go back to the first set of 10. I'm going to give you a couple of hints because there's a couple of these that are tricky balances because they're not the typical reaction types that we've gone over. Like, for example, question number 4. Okay. So 2 things about question number 4. A lot of people want to say that that's nitrite, which is a polyatomic ion. Is it? It isn't. It can only be a polyatomic ion if it's in an ionic compound. This would be its own molecular compound. Please name it as such. Okay? Do not write nitrite for that. It is not nitrite. Give it a proper molecular compound name. Okay, and then the big trick on this one for balancing is that when this breaks down and decomposes, it breaks down into 3 different things, all of which contain oxygen. Right? So it becomes a bit of a tricky balance. So my suggestion here would be to look at your nitrogens and probably, I don't know if I necessarily balance them first, but they're kind of the tricky part. Okay? You can't really balance your oxygens first because they're in the biggest amount. Okay, but they're everywhere, so it's tough to do that. My suggestion would be this. On this side here, there's an odd number of oxygens. Okay? Right now, it looks like there's 5. But on this side, there's 6. Okay? So I've got an odd number on one side and an even number on the other. My suggestion would be to get rid of the odd number by putting that there. That's going to give you a pretty juicy start for that one. Okay. Number 7 is similar to that one. And I would suggest for number 7 that you have a look at this. Ammonium, which is here, breaks down on this and it becomes ammonia, like what we had in our lab, and these 2 other compounds. So I would suggest you should probably balance the nitrogen first. Okay, so look at how many nitrogen there are here and balance it first. Okay. And I think that's all the hints you need on that. You might want more, but that's all that you really need. You can handle the others. All right. I'll figure out a due date for that tomorrow. Okay, it's not going to be due tomorrow. I'll figure out a due date tomorrow, but you will have all the time after our quiz to work on it in class. So you should get pretty far along on it, really. Okay. But I will probably want it Wednesday or Thursday of next week so that I can mark it and give it back to you and go through it before your exam so you have it to review and study. Okay? But we'll figure that out for sure tomorrow. For now, you got some time and get started on it, see how much of it you can get done.